When an electron in an excited M0 atom falls from L to K shell, an X-ray is emitted. So what it says? Read. These X-rays are diffracted at an angle of 7.75 degrees by planes with separation of 2.64 angstrom. What is the difference in energy between K shell and L shell, assuming a first order reflection? Right? Now, there is an atom M0, right? See, this is your atom. What is the name of this atom? It is M0. Now, in this, students, what is happening? Your electron is moving from K shell to L shell, and it is emitting out what? X-rays. Now, these X-rays are allowed to fall on the crystal. Right? Now, when these X-rays, they fall on the crystal, what happens? They get deflected by a particular angle, right? Now that angle is given to you, sorry, this angle is 7.75 degrees, and the distance between the two planes, that is equal to 2.64 angstrom. And this angle of deflection is 7.75. So what is the what do you don't know from here? You don't know is the wavelength of the emitted X-ray. You don't know? How will you find out? Let's see. We have got Bragg's equation with us. N lambda is equal to 2d sine theta. Now if you have got the wavelength, can you find out the energy? There is a difference in the energy. Say, the wavelength of the X-ray emitted from here, or the energy of the X-ray emitted from here, will be equal to the difference in the energies of the L and the K shell. Right? And this delta E is equal to hc by lambda. Now we know h, we know c, we don't know lambda. Can we find out lambda from this equation? Now your lambda is equal to 2 into, what is the distance between the two layers? That is 2.64 into sine 7.75, and that is divided by n. N is what? It is the first order reflection. So n is equal to 1. Now what will be our wavelength over here? It would be 2 into 2.64 into sine 7.75. And this is equal to 0.7120, right? And this is angstrom. Got our wavelength, right? Now, can we find out the energy of that X-ray? Or, yeah, the energy of the X-ray will be what? It will be the difference between the energies of the two levels. That is your L and K. So, this delta E will be equal to 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 meter per second. Right? And that has to be divided by what? The wavelength, 0.7120 into 10 to the power minus 10 meters. Now this is going to give you the energy difference. Now that is equal to 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8, and that is divided by 0.7120 divided by 10 to the power minus 10, and that is 2.79 into 10 to the power minus 15 joules. So students, this whatever is the difference in the energy, or whatever is the difference in the energy between the two levels, the ray emitted will have that particular energy, or that particular difference in energy is emitted as a ray. So what is the difference in energies between the K and L shell? That is equal to 2.791 into 10 to the power minus 15 joules.